Here's a quick example for you about how to do mole calculations again in case you're having trouble. First thing I would do is make sure you have this little road map written down for yourself. Notice that you need to use the molar mass to go between grams and moles. You can write that either as the number of grams in 1 mole, or 1 mole contains whatever number of grams. Depending on which one you use, you'll cancel out the right units with that bottom term. Between moles and number of particles, you'll use Avogadro's number, which can be written as either 6.02 times 10 to the 23 particles in 1 mole, or the flip, 1 mole contains that many particles. Again, whichever one you put in the top or bottom depends on which unit you want to cancel out. Let's look at this problem here. Number 3, 25.5 grams of carbon, 2 atoms. Start by writing down what you know. To go from grams to atoms, I first have to go through moles using the molar mass. I know that I need to cancel out grams, so I'm going to have the mole part on top. 1 mole of carbon is 12.01 grams. I got that from the periodic table. Grams cancel. Now I have moles of carbon, but I want to know how many atoms of carbon there are. From moles to atoms, which is a particle, you use Avogadro's number. I will need to put the mole part in the bottom to cancel it out. So 1 mole of carbon contains 6.02 times 10 to the 23 carbon atoms. Moles cancel. We're left with carbon atoms in that upper right-hand spot, which is the unit that you want to have for your final problem. When you solve that, and sorry you don't have much room, if you want to do these on extra paper, you can. Just punch it in on your calculator. 25.5 divided by 12.01. If a number's in the bottom, you'll divide by it. Times 6.02 EE button 23. And I get this number, 1.27818 blah 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 times 10 to the 24th power. I'm going to go to 3 significant figures, so I'm going to call it 1.28 times 10 to the 24th power. Carbon atoms. Ta-da! Done.